In any situation where we're dealing with very large or very small numbers, it's helpful to have a way to concisely write those numbers. And that is the purpose of scientific notation. So let's review the rules for how this works. So let's start with, first of all, what scientific notation is, and that is a number which is greater than or equal to 1 and less than 10. So you can say it's between 1 and 10, but also including the number 1, times 10 to some exponent. Right? And those exponents are always going to be integer numbers, such as -3 or 15 or even the number 0, but you'll never have a decimal or a fraction as your exponent. Right? So when we're dealing with very large or very small numbers, we can follow a consistent set of rules to be able to write those numbers in scientific notation. So for example, let's look at the number 3042. Right? So what we want to do is place a decimal in this number so that it is between 1 and 10 or the number 1 itself. All right, so to do that, we would need to put the decimal right after the 3. So let's go ahead and do that. All right, and right now I'm not going to write the equal sign between these numbers because that's, of course, not the case. So what we've done by adding the decimal there is we've made the number actually quite a bit smaller. Well, how much smaller? Well, putting a decimal there, essentially we've moved it from at the end after the 2, right, back to after the 3. So we've moved it back 3 places, and that happens anytime you divide, right? And divide by what? Well, in this case, we would divide by 1,000 to make that happen, right? Or 10 to the 3rd power. So what you want to do to finish the scientific notation, we want to write 3.042 times 10 to a power, and it's whatever power would be needed to move the decimal back to where it was, or in the original number. Right? So from 3.042, I would need to move it 3 places to the right, right? Or I could say multiply by 10 to the 3rd, and then that would equal 3042. Okay, let's try the same thing on the next number. So to be a number between 1 and 10, I would need to have the decimal point between the 1 and the 2. Right? So if I wrote this as 1.2, right, and then times 10 to what power? All right, it would be whatever number of decimal places are needed to put that decimal back where it should be. Right? So from between the 1 and the 2, I would need to move it back 1, 2, 3, 4 places. Right? And we use a negative sign to indicate moving to the left. So this would be 1.2 times 10 to the -4th. All right, and then our final example, this one almost appears to be in scientific notation because it's a number times 10 to an exponent. The problem here is that 226 is still not in scientific notation form because it's not between 1 and 10. All right, so we still need to move the decimal, so I'll make that 2.26, right? And then what would I need to multiply that by to get the decimal point back to where it should be after the 6? All right, well, the decimal would need to move 2 places to the right. All right, so this would be times 10 squared. All right, now this piece just represents 226, right? But we also have this additional times 10 squared, so I don't want to forget that. I'm going to write that in, right? And then I need to combine these two because scientific notation just has one 10 with an exponent after the number. So now we can bring in rules for combining bases with exponents. Right? So 10 squared times 10 squared, you would add the exponents, and that would be times 10 to the 4th. And you can always check this by just checking the numbers in standard form and making sure they're equivalent. So 226 times 10 squared would be 226 and then 2 zeros. And then 2.26 times 10 to the 4th, we would move the decimal 4 places to the right. So it would move after the 2, after the 6, and then we would fill in 2 more zeros. And then you can see in standard form that those two are equivalent. All right, what about converting from? Well, it's as simple as moving the decimal point however many places the exponent indicates. So we would start with 4.01 and move the decimal point 2 places to the right. So this would equal 401. Right? 3.6 times 10 to the 6th, you'd move the decimal point 6 places to the right. Okay, so you'd move it once, right? And then it would be to the right of the 6. And then if you don't have any other numbers, then you would fill in the rest with zeros. Right, so we would add 5 zeros here. All right, and then finally 5.7 times 10 to the negative third. Now because the exponent is negative, we move the decimal 3 places to the left. Right, and we need to fill in 2 zeros to make that happen. So this is 0.0057. Sometimes it's also necessary to multiply or divide numbers in scientific notation. So the easy way to do this, I think, is to multiply just the numbers themselves that are between 1 and 10, and then to go back separately and multiply the tens with the exponents. The reason we can do this, you may remember that multiplication is commutative, meaning you can switch the order around, and it's associative, meaning you can change where the parentheses are. So we could actually look at this problem as just 4 different numbers all being multiplied, and you can do those in whatever order and whatever grouping that you would like to do. All right, so with that being said, 6 times 4 is 24, and then 10 squared times 10 to the 5th would be 10 to the 7th. You would add the exponents, right? Are we done? If we need this in scientific notation, then we have one more step because 24 is not a number between 1 and 10. So we need to make this 2.4, right? And then this would be 2.4 times 10 to the first power to get that to be back to 24. And then we also have times 10 to the 7th. So altogether this would be 2.4 times 10 to the 8th. Dividing works very similarly. You can divide these in any order, so we can divide the numbers first and then the tens with the exponents. All right, so 4.2 is actually exactly half of 8.4. Right, so if we divide just this piece, you can check it on a calculator if you like, but that's going to be 0.5. And then you may remember dividing with exponents, you subtract the exponents. So this would be times 10 to the negative 2 minus negative 5, right, which is plus 5, so that would be 10 to the third. All right, and then same thing, because 0.5 is not between 1 and 10, we have one more step. So I want to make this 5, and then I would need to move the decimal back one place to get that to be equal to 0.5, so that's times 10 to the negative first, and I still have times 10 cubed. All right, so all together, that would be 5 times 10 squared, adding the exponents. And finally, let's talk about adding and subtracting with scientific notation. All right, now this one, we do, because of order of operations, we do need to multiply before adding or subtracting. So there's no shortcut for this one. We can't, for example, we can't add the 3 and the 5 and then go back and add the 10 to the 6th and the 10 squared. It doesn't work that way. So instead what you need to do is actually just convert the numbers to standard form, then do your addition, and then put it back in scientific notation. All right, so 3 times 10 to the 6th would be a 3 with 6 zeros, all right, or 3 million. And then 5 times 10 squared would be 500. So you can see why we can't just add the 3 and the 5. It's because they're in different places. The 3 represents millions, while the 5 represents hundreds. Right, so if you added those and made 8, then the question is, well 8 what? It's not 8 million, it's not 800. It doesn't quite make sense. Okay, so this becomes 3,500,000. And then if we wanted this in scientific notation, it would be 3.0005. Okay, and then we can drop those other 2 zeros. And then times 10 to what power? Well, we would need to move the decimal from after the 3 to after this last 0, so we need to move 6 places to the right. All right, so times 10 to the 6th. And then how about subtraction? All right, so same thing. We can convert these to standard form first, then subtract, then put it back in scientific notation. However, there is one exception here. Because both of these have 10 to the same exponent, that means that the 2.3 and the 1.6 are actually in the same place. So if we backed up, to our previous example, like if this 10 squared, if that had been 10 to the 6th, then I would be adding 3 millions and 5 millions, and that would make 8 millions. Okay, so you can take the shortcut of just combining these two numbers together only if the exponents match, if this is in scientific notation form. All right, so we actually, in this case, can do 2.3 minus 1.6, right, to get 0.7, and then this would be times 10 to the negative 22nd power. And then we'll make one adjustment for scientific notation. This would be 7 times 10 to the negative 1 times 10 to the negative 22. Right, or altogether this would be 7 times 10 to the negative 23rd power. All right, and again, just to reiterate, if these exponents had been different, then we would have needed to do this a long way and write those two numbers out first.